Okay, I'm going to tell you about myself as I go along in this program, a couple of things, because this is something I am at this end of my life sort of pulling together the meaningful parts of things into this study on sustainability. So as I go along, I'll just kind of explain the history of some of that. So, here we go. Okay, now I need this. And I'm not really used to doing this. Please forgive me if I do the wrong thing. So we're going to talk about sustainability, but about agricultural sustainability. Okay? We're going to base a lot of the sustainability information, the scientific information, on the UN program called Age of Sustainable Development. And Jeffrey Sachs, who is an economist, was on that huge committee that put that plan together. He gave, I saw him on Coursera, a whole 13-week course about over a year and a half ago. And not only did he speak well, but he made me cry. And the gentleness and the intensity with which he talked about what the state of our world is and what it's going to take to change things. So that got me into this whole big business. And he has a book. It's called The Age of Sustainability. His name is, I just told you and I forgot. Oh well.
Jeffrey Sachs.
Jeffrey Sachs. Thank you. That's another thing going on here. Anyway, you're not old enough to understand this. Anyway, so what I want to talk about is the agricultural part of it, and I'm going to start with the big picture and work down to ultimately the small picture, that's us in Master Gardeners in San Diego, and tell you about a project that I'm getting going myself as part of Master Gardeners. This one goes forward, right? Yes. All right. I married a man who had, on the one hand, wanted to be rooted because he loved plants, but on the other hand, he really wanted to see the world. And so we went in the early 70s to the Philippines in the Peace Corps. We went with a child, which was really brave of us. She was like 15 months old, who turned out to speak the most beautiful Tagalog you have ever heard. Unbelievable. But anyway, and I fell in love with that place. We were there for 2 years. I wanted to stay a third year, but I realized that we had a kid that didn't speak English and we probably should take her home. But I loved it. It was, people lived off the land, even in cities. They go to the market every day. I went to the market every day to get my fresh food to take it home and eat. If any space they had anywhere had trees, garden, whatever. Stuff was just out of the ground. And I didn't really get to follow up on that so early in my life, but it made this huge lasting impression. And it was beautiful. Now that's not the Philippines. Anybody want to guess?
Hawaii.
This northern Vietnam.
Oh.
So we've been going overseas ever since to Asia, usually with global volunteers or something where we would teach for a while and then we go travel around. So we went to Vietnam a few years ago. We went to the northern part, which is just gorgeous. And they have these wonderful indigenous tribes that make things by hand and so on. But, you know, I just went crazy. I just felt like I was back home in the Philippines. So it had a huge impression on me. When we came home, now I had a degree in music when we went. That's what I got before we got married. But when we came home, I went into biology and toxicology and ended up with a PhD in genetic toxicology. And that now has expanded into a number of other areas. I ended up teaching in college and then teaching in high school, and I became ultimately an environmentalist. Okay? So that's what I wanted to tell you about me. All right, so here we are. Here we are. The projected population, if we don't get our act together. 8,000 is almost for sure. 8 billion, I'm sorry, is almost for sure. 10 and 12. 12 is if we continue as usual. If we don't change things, 12 billion, okay, by 2100 or more. And so this is really, all of our problems are coming from overuse of resources. And this is one of the things that we've got to deal with. Either do something about that and stop it right now, or also do something about using different resources, especially the ones that contribute to global warming. So, what I want to know is, how can we grow food for 10 to 12 billion people? We got to change our ways. So this is the outline of the talk. I'm going to talk about the planetary boundaries, which is what was set out in this program, this UN program. And then I'm going to relate them to agriculture. Then we're going to talk about industrialized agriculture in our country mostly, you know, wherever they do industrialized agriculture and what the problems with that are. And then go into sustainable agriculture, what we really can do and need to do to deal with this global warming issue. And finally, you know, whatever, a grassroots movement, what can we do? What can we do? Okay. So, global warming, at this point, if we don't do anything different, we're going to have 6 degrees centigrade increase by 2100. That's like 9.5 or so degrees Fahrenheit. Do you want to be that much hotter? That's if that's business as usual, okay? So we have to do something. What they have done, let's see, where's my, here it is. What has been done here is they've taken the data, this is the UN program, the UN study, taken the data available on these various aspects, there are 9 of them, and put them together in this graph, which kind of shows the planet, its boundaries, okay, and kind of the outside boundaries for the absolute last tolerable level of stuff, and the inside boundaries where things are still kind of okay. And then we look at things like biodiversity loss. That's really at the outside, okay? Nitrogen cycle at the outside. Phosphorus cycle is not so bad yet. Climate change, we've got it not so bad yet. That's because we've got like 4 or 6 degrees to go yet. Right? And so on and so forth. Some of them they don't have data, but they know there's damage that's occurring. Okay? So these are called planetary boundaries, the outside boundary. And we call anything that's moving there and out crossing the planetary boundaries. So that's what, there are 9 of these, so here's the first 4. And what I've done is put asterisks by the ones where agriculture has a major effect. Okay? So now agriculture is intimately related to these planetary boundaries. Number 1, just human-induced climate changes, and that's our greenhouse gases. That includes carbon dioxide and methane and nitrogen oxide and so on. They talk about it in terms of carbon dioxide equivalents. We know that, for instance, that CH4 has about 25 times the holding capacity heat that CO2 does. However, it doesn't last nearly as long. So they put all of those factors together and come up with what we call a carbon dioxide equivalent. Okay? So human-induced climate change, and that has to do with the growing amount of these atmospheric gases that are warming up the planet and disrupting systems simply by warming things up. Ocean acidification, we know that carbon dioxide dissolves in the ocean from the air. Okay? It becomes carbonic acid, which then makes the ocean water more acidic, which then, once it reaches certain levels of acidity, damages shells on any kind of shellfish, damages the coral reefs, and so on. And we're already at a disastrous state with those. All of our wonderful coral reefs are at least under siege, if not pretty much dead. But
The bicarbonate ion in the human being typically buffers acid and leads to
But
neutralizing
not in this
pH.
case, not in this case.
But not in the ocean.
Yeah, yeah, don't ask me.
Repeat the question.
He was thinking that maybe the bicarbonate ion should act as a buffer in the ocean, but it really doesn't. It seems it's the major.
Contributor to acidic.
Yeah. I it's been a long time since chemistry. Oh boy. Okay. So let's see, where was it? Okay. So number 3, ozone depletion. We know about that. We're kind of at a static state right now because the world really got together and did something about those chlorofluorohydrocarbons. Okay? That was the first and maybe only time that such a thing has happened on a worldwide basis. Is somebody out there? Well, maybe not. Okay. Anyway, and I was going to say, the reason that I have those asterisks by the climate change with the CO2, soil, good soil, has about somewhere around 10 to 15 times as much CO2 sequestered in the soil as there is in the air. Okay? So what can you think of agriculture does for that?
Releases it through the process.
Yeah, you go out there, you till the soil, stuff just comes in. Yeah. So agriculture adds a tremendous amount of CO2. Agriculture as we do it. Okay? Ozone depletion, all right, we talked about that. Water pollution. Nitrogen and phosphorus, and of course a lot of other things. In terms of agriculture, what happens here is that with the use of fertilizers, there's so much in the soil, and I'm going to talk about this later on again about the mechanism for this, but there's so much nitrogen and phosphorus and so on in the soil. They are charged particles and they're easily leached. Easily leached with too much water, too much rain. Even too much rain can do it, right? Too much water, whatever. So they put all this fertilizer in there. It can't get used up by the plant. They put it in excess because we want the plants to grow fast and big, right? Big and green. Well, the problem is they're out of balance. They don't put everything in to keep a balance. So the nitrogen doesn't get used and so on. And that is why it can then get leached into or run off into waterways. And other chemicals as well. It's not just those, but those are really bad. Okay. Freshwater depletion. 70%. I couldn't even believe this. And I really wanted to question it. 70% of the fresh water, at least in our country, I don't know if this applies, but I think this is supposed to apply to the whole world because this comes out of the UN. 70% is used for agriculture. And what happens if it's used for agriculture that's industrialized agriculture that has all those chemicals and fertilizers, right? Okay, it gets polluted. So our agriculture, our form of agriculture is seriously polluting fresh water. I mean, they say basically there's no such thing. Destruction of natural lands for ag. Now here's this battle going on between, well, we need more room for houses and cities because our population is growing, da-da-da-da-da-da-da. Where are they going to get it? Where are they going to get it in whatever's the nice land that's easy to build on? They're not going to go to the top of the mountain. They're not going to go to the middle of the desert. They're going to go where there's nice land. So there's this battle between the agricultural community that needs land and the building community that needs to build cities. So a lot of agricultural land has gone to city building. And there's a big battle going on, evidently. It sounds like it, at least. So, biological diversity. Now I'm going to talk to you, I'm going to give you the name of this right off the bat. I was reading some guy's blog not too long ago talking about soil. And he talked about the microherd. Microherd. And I loved it. The microherd.
Herd?
Herd, H-E-R-D. We'll see it up here. You'll see it.
Oh,
All those little guys up and in the soil or on top of the soil, involved in some way with the soil. That's the microherd. And the microherd does the work of the soil that allows plants to grow until you kill it off with fertilizers and stuff like that. So when you lose biological diversity, it's not just the birds and the trees and the lions in the forest and so on. This is the biodiversity that's going to kill us if we don't take care of it, or the lack thereof. Biodiversity in the soil. We'll be back at that for quite a while. Okay, aerosol loading, air pollution. A lot of this is just the chemicals that come from running all of that farm equipment, from all that fertilizer and all that stuff, all those pesticides that go into the fields and end up in the air. So it's just all of that. So we are a big contributor. And finally, they left us out of number 9, thank goodness, chemical pollution. That gets to be part of the petrochemicals from steel and mining and stuff. So they get to have that one. Okay. So, trespassing on planetary boundaries. This is a quote from the book. When human pressures are greater than the natural system's ability to absorb or clean themselves, then there are major changes in ecosystems that threaten human well-being and survival, especially in poor areas. And I want to tell you that more than a third to half of this book is dedicated to people from the third world. To those, Africa is the one I always think about, but Africa, the Middle Eastern area, that whole region of that whole set of continents over there. Subsistence living is the typical situation in Africa, for instance. Subsistence farming is very detrimental to soil. Very detrimental. And even though people are barely eking out a living and they're not using machines and they're not putting in a lot of fertilizer and they're not doing all of that stuff, it's just that they are overworking the land so badly that it cannot recover and cannot be fertile. So they're included in this whole idea of doing something about agriculture throughout the world so that we can have fertile soil and not be crossing all the planetary boundaries all the time. And here is a place, this is from Tibet. I went to Tibet a few years ago. I spent 6 weeks on the road, interesting roads, driving in the outland, not to Lhasa, but out in the outer regions where the Chinese had destroyed all of the monasteries and so on, where people were quite poor, very rural. And a lot of it was in the very high mountainous areas. Up is hot. This woman lived at about 18,000 feet. Okay, and they don't really grow crops, except that there is grass. I'll show you that later on at the end of the thing. There is some kind of ground, but this is permaculture. What do we call it when it's frozen? Permafrost. Thank you. Yeah. Okay. And they have yaks, okay, herds of yaks, and very little else, but they really make the best use of that, and they survive. And they don't have too many children, and they have relatively comfortable environments. Now, she was really at this very, very high altitude. They're not all so high. Serious Buddhists, pleasant person, managing under those extreme circumstances. Okay. But this woman would be considered by the UN to be poor, and by me and you. And so the sense is that these are the kind of people that also need somehow to be helped, to be brought into a sustainable living style, a sustainable farming style. But I really liked her. She spoke to me in a really serious way. Okay, so that's the planetary boundaries and the UN program. Yes, sir?
Did she consider herself poor also, or was she?
I don't think she knew the difference. I think it's a hard life. You could see, for instance, the face, the bird, all of them. There's no ozone and stuff to protect them, hardly, or not enough. And so you could see the bird on the faces, and yet those kids were out running around, and they had animals, and they weren't in that picture. They were scared because I was there. They didn't know what to do. But they're living, and they're self-sufficient.
So what's wrong with that?
So what's wrong with it? Well, yeah, I go with you.
Yeah.
I go with you. The only thing that I have to say is in situations like that, when people get a different opportunity, they always go for more food, more housing, more comfort, more clothing, whatever. So, and then, pretty soon it gets out of style, right? I mean, out of
Control.
control. Yeah. So, I don't know, what's wrong with it? Yeah, okay. I saw a hand. Yes, sir.
I was just saying, because you talked about how you try to get everybody into this kind of like level of living. If they're up 18,000 feet and they're surviving, that means you got to bring them down because you can't bring earth growing whatever
Yeah.
things up.
Yeah.
So now you're making the problem bigger because you mentioned earlier,
Yeah.
no one wants to go to the mountain, no one wants to go to the desert.
Yeah, that's right. Yeah.
So you're
Yeah.
compounding the problem by, in that case, 3.
Yeah, well, I don't know how to answer that. I don't think it's up to us to move them. But what is happening in Tibet is, of course, the Chinese have become very active, and they are moving people, and also making the kids go to school. And so there is a lot more communication going on there. And I think that in time, like it happens everywhere, things will change. These guys will start going to the market. There'll be some source of income, perhaps. So I don't know. Interesting to watch. Except, I'd love to go back and see, but I have a rule. When I love a place, I never go back because I don't want to lose what I loved about it. So I will never know what happens to her. But I hope it's good. Yeah.
My husband's from India,
Mm-hmm.
and I just want us to be careful because we do have a tendency to overlay our priorities and our perspectives on other people's.
Exactly.
And when we travel in India and we go to villages that we might consider poor, they do not consider themselves poor. They're very happy. And we just have to take care of respecting others' ways of life when we do this kind of work.
Absolutely.
That's my only request, is that we just can't go in and do to
This is
people
why I
what
don't go back.
We must.
This is why I never go back, because I don't want to see those westernizing changes.
Right.
Because I know there was a huge integrity, right? Like in the Philippines. We had a lot of gay people in the Philippines. Were they out there? No.
And given
No,
time,
they were part of their families, part of their culture, and so on. No, all kinds of things like that, yeah.
And given time, we are finding that their agricultural practices.
Oh, now
are
stop,
much
you're getting
more-
ahead of me, stop.
I ask us to be careful. is all.
Yeah, no, I so love those cultures. I love the way they feel. I love going to the market. 2 years I went to the market every day. I have to tell you the story about the chicken lady. She had these chickens. And when I first went, I didn't know anything, right? Didn't know anything. I go in, I have this basket. I say, I want a chicken. Okay, so I'm going to buy a chicken. So she picks up the chicken, she puts it in, wraps it and puts it in my bag. And I go home, and I put it in the sink, thinking, okay, I'll get to it in a minute. And after a while, I go back and I say, oh, okay. So I start, where's the plastic bag? Where's the stuff inside? It had not been cleaned out yet. She just gave me a chicken that had been plucked and its head cut off. You know, stuff like that. So I go back to the market and I tell her that. So she, for 2 years, every time I bought a tree, she told everybody within earshot. And it was a good story because it made me look silly, right? Or like I'm not perfect, and I loved it. Lots of things like that. I love that. I so agree with you. I wish the whole world could just stop as long as everybody gets hungry. You know? Yeah, okay. So, but it won't. It won't. Okay. So the damaging effects of industrial agriculture. So, although fossil fuels were discovered and put into action in the 1700s, it was really in the 20th century that we began to capitalize on those advancements for agriculture. It was really after the Second World War when people had developed all of these chemicals and all of these equipment, all of these machines and so on. They got the Green Revolution. Increased yields of agriculture, we're talking. New strains, fertilizers, new pesticides, heavy machinery. So all they had this huge technological breakthrough. And all these guys that had learned all this stuff and came home and needed something to do, right? Okay. So there was a big increase in production in agriculture until the 80s. And then that started to drop. So there was this big increase, and then instead of going straight up, it started to kind of fall off. And by now, that rate of increase is basically just now falling downward. Okay? There's been a decline in the rate of increase, and now we're going downwards. Now, it's not because we're not doing as much land, or as much farming, or as much pesticides, or as much anything else, or as much making the strains. It's because the land is so imperilled and so damaged that we can't put enough fertilizer on it to make it work, to make it productive like it used to be. So we started crossing the planetary boundaries. There you go, monoculture. Ain't that pretty? Or as you can see, same thing. And what happens when you have monoculture? What do you lose?
Biological diversity.
Diversity, biodiversity. Huge amounts of biodiversity, right? So you get some kind of a new pest in there. What's the chance you're going to be able to do something? Or the soil can do something, or the plant, without pesticides? None. None. Okay. Tilling. Turning up all that soil, letting go all of that CO2, breaking up all of the soil structure that I'm going to show you in a little while. Emitting all of the CO2 from the tractor. And look at the land out there. Probably will get tilled too. And erosion. Nothing left to hold the water. No little hills or anything anywhere. Okay, so ags trespass on the planetary boundaries. We already said this, 70% of Earth's fresh water releases large amounts of CO2 into the atmosphere by tilling the soil and running farm machinery on fossil fuels. Uses fertilizers that disrupt soil, nutrient, and biome balance. Causes runoff of nitrogen and phosphorus to water, so we get eutrophication. You know how that works? Okay, these things get into the waters, so they're fertilizers, so the algae and things like that grow really fast. And they've outgrown everything else, and then they start to die. Bacteria come in and feed on them, and they use all the oxygen between them that's in the waters till everything dies. Everything dies. Okay, uses fertilizer, we did that. Uses pesticides that kill, and here's my favorite word, the microherd. Impede nutrient cycling and damage soil fertility. And climate change, in reverse, also affects agriculture. We've got drought, diseases, and weather extremes. We've got polluted water and limited water. More pests, new pests, different. We've got a change in climate. We're going to get different things coming up to visit us, right? Limited expansion opportunities, but a growing population. Social disruptions, and economic downturns. Okay, So we really, this is all based on what the UN is saying. This is, you know, I mean, I get involved in it, but this is their work. So, the challenge for agriculture, we have a future need for increased food, fiber, fuel. This requires approximately 20 to 25% cropland expansion, and it's hard, and this is in the world, hard to imagine though, very hard to imagine that. And actually the upper number that you hear is 55%. Now, I mean, where's that going to happen? I don't know. This is a conservative number here. But our current yield is decreasing due to infertile soils. So how much land use can change, how much land use change can occur before there's irreversible damage to the planetary boundaries, at which point we just can't fix it anymore. We're in a disaster. And that's a good question, and I'm not going to answer it. Don't know how. Okay. So the third part of this talk is say, okay, what do we do about it? First, we're going to start talking about the lessons from traditional agriculture, and then go on to talk about the soil. Traditional agriculture uses natural ecosystem services, no fertilizers, no pesticides, herbicides, physical disturbance, etc. None of that. Now I think back to the kind of farming that I saw in the Philippines. A lot of it was rice farming, of course, but not all of it was, because you could buy all the vegetables and everything you wanted in the market, and it all came around locally. There was no machine there, ever, tilling the land. Whatever was done by hand labor. There were lots of people, and I'm going to show you a picture of this at the very end. There are a lot of people out there working on that land. So it provided jobs for the families and for everybody else, and so a way of living, a way of life. And it was very frightening. We were in this small city in the Philippines, and I went to the market every day. We had a third Peace Corps volunteer there who worked up in the mountains with the farmers. And they were the people who were bringing a lot of their food down, and I would talk to them. Okay, they were the ones who were selling vegetables and whatever else. Well, and just a little aside. For example, if you bought some beans, somebody took out one of the kids' school papers that had been written every square inch all over it and folded that into a little thing, whatever you call that. Beans in it, folded the top down. There you go. There's no waste. One time we got really called out because we had trash. No, you have to reuse it. You have to reuse it. If you can't give it to the pigs, do something else with it. So there was that whole mentality. So just use everything. Use everything in some good way. And anyway, so I was going to tell you about this guy. He said, this was at a time in the early 70s when the U.S. had decided we could no longer use DDT. They had outlawed DDT. So what did they do with it?
They sold it.
They sent it to the third world without much in the way of instructions how to use it or anything else. So he was faced with that dilemma. That the U.S. was sending it there, and he didn't want them to use it because they didn't know how to, as far as they were concerned, they could pour it on straight. I mean, they didn't know whether to dilute it or what else to do. Nobody was helping with that. So his whole job became trying to teach them not to use it.
Wow.
Yeah, and that happened all over. So other than that, they just used natural methods. They didn't make or use other kinds of chemical things. And yet they did understand a whole lot of things about companion planting and all of that. So, okay. So traditional ag adds composted waste, both plant and animal. In fact, there's almost always a water buffalo or somebody else out there pooping, in the crops. So that gets used. Avoids tilling, uses appropriate crops for the land and the climate. Avoids compacting the soil. Of course, these people are weigh about half of what I do. So Not the same thing as me walking on it as it for them. And respects and cares for the soil and its work. So here, and you know, I'm not sure where I don't remember where this comes from, probably in Africa someplace, but anyway, a lowland farm. And there is the same woman up in her highland, 18,000 feet plus. And there is a yak, and you see there is something growing up there. There's stuff growing. What they do is build these big composts, like the size of this room perhaps, okay? Compounds, and wall them off for 2 or 3 years so that the yaks don't get in there and eat on that grass. I don't know what it is, it's whatever it is. So that builds up. So they build those all over. And then every second or third or fourth year, let the guys come in and feed on that and wall some other ones off. And it works. It works. This is the most extreme that I ever saw. Okay, most of it is 1,000 feet lower, and it's quite a bit better, quite a bit more lush, and you feel a little better about having people live there. And then this is lowland, and again, he's probably really tearing that ground up more than I think he should, but nonetheless, it's not the same as going in with a real tilling machine. All right, so now this is again trying to get healthy agriculture. Natural soil resources. Soil is a highly complex mixture of minerals, organic material, and the microherd. The microherd does the soil's work, if you will let it. And I should tell you that at our, it's not a conference, but on June 4th, the seminar, Nancy Helt, who is basically involved with the community gardens and so on and so forth, she's got me involved in this composting project, and she is putting together a wonderful tent. A tent that's going to be about healthy soil, healthy bodies, healthy soil, something like that, I forget. And so I was helping her do some research on this, and I found this, I loved it. 1 liter, which is about a bottle about like that, right, of healthy soil, there are 100 trillion bacteria that decompose matter and fix nitrogen. Nitrogen fixation, we're also going to talk about. That's very, very important. Nitrogen is a hard nutrient to get enough of. So we'll talk more about that. 10 trillion actinomycetes that help decompose matter. 100 million fungi that decompose matter and transport nutrients into plants. Okay, one of the things that can happen, especially we're used to this happening with beans, with legumes, but it happens with a lot of other plants too, that the roots will secrete some kind of a sticky, sugary substance on their outside, and that pulls in, that attracts a lot of things, especially fungi, that will then deliver their nutrients right at the root of the plant. Okay, so it can be taken up. So, and we're going to talk more about that, but that's why, that's one of the main jobs that fungi do. They're very good at that. Okay. 10 million algae, and algae are photosynthetic, so they can assist with nitrogen fixing in plant roots. Nitrogen has to be fixed. Nitrogen from the air has to be fixed to a different chemical form by somebody. Usually we talk about it as by plants, but in this case we've got algae that also can help. And 10 million protozoans, consume soil bacteria, 10,000 nematodes, which are roundworms. They feed on some of those other guys up there at the top. 500 mites and insects that decompose matter and eat nematodes. So you're getting the idea. Everybody gets eaten here somewhere along the way, right? Okay? And 500 mice and insects that eat nematodes, oh, I said that. And then 2 earthworms that decompose matter and deposit castings and make burrows. Okay? So this is a fun drawing. Supposedly this is, like it says up there, first level consumers, second level consumers, third level consumers, and here the first one's down here, the actinomycetes, the mold, the bacteria. Those over the side, they're also first level, the nematodes and lanceolate and so on and so forth. And then somebody else, the second level, they eat the first level, and the third level, they eat the second level, da 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 da. Very much like the old standard pyramid that we use for herbivores and all of that. Okay? But look at all those things, and that's just a few. Okay, so we're going to talk about soil structure. Those are the things that you see that are in soil, that can be identified in soil. And I'm just going to read this. Soil consists of organic matter and clay or silt or loam with small and large tunnels filled with air and water for the microherd to live in. Okay? So soil needs air, soil needs water. Tunnels are different sizes. The smaller ones, the air will go in. I think it's that way. And the other ones, the water will go in. I forget which way it goes, but one of those. And then all the critters run around in there, have their little dens where they do their thing. Okay? So it's full of holes and tunnels and structure. The microherd is its own ecosystem. It's not there because there are plants there. It's there for itself. It evolved in that place. That's its home. One guy's, whoops. What does it say? One guy's poop. Oh yeah, I forgot that one. One guy's poop is another guy's breakfast. Okay? That's just the way that works. And it goes that way until the food is passed on and finally metabolized to fundamental nutrients that can be used by the plants. That's just by accident, not by purpose. Just works out that way. Okay, so there are 2 cycles that are really important, carbon and nitrogen. They're unusual, and that's why I want to talk about them. These are required by all living things, you know that. They come, both of them are from the atmosphere. That's their source, basically. Carbon dioxide and nitrate, N2, okay? And they are converted by plants, in the case of carbon, and the microherd, in the case of both, into nutrients for everybody in the soil, everything in the soil. They have very complex cycles, and without the microherd, there would probably be no plants or animals because those kinds of conversions just wouldn't happen. It's really important. So let's start with the carbon cycle. First of all, dead plants and animals contain lots of carbon-based molecules. Okay, that's what we're made of. You all know about, CO2, 6 CO2s from the air taken in by the plant, made into a carbon chain of 6 carbons and 6 oxygens and some number of, I think, 12 hydrogens so that you have a molecule of sugar, right? That carbon-carbon bond is crucial for life. There is no life without it. And making that, what plants do, is absolutely necessary. But that little atom or that little molecule of sugar ain't going to do much all by itself. It needs something to help it change form or do whatever, to become DNA, to become fats, to become whatever is left, proteins. And well, sugar is the basic energy source, right? So yeah, but become all these big, fancy molecules. Okay? One of the keys for that is nitrogen. Nitrogen is a reactive element. And so it is able to, where carbon is very stable, nitrogen can bind and unbind and do all these other things. So the two of them are really crucial. So when I say that the carbon-based molecules that are decomposed by the microherd for their own nutrients, the end products of carbon decomposition, once in the soil, once everybody's used these molecules pretty much and melted them down to the final last bit, one of the end products of carbon is humic acid. You've heard of it. It's, what those are particles, kind of like plates is how they're described, that form from this very stable part of carbon. It really doesn't have much energy left in it, so nobody wants it too much anymore. It serves a wonderful function. And I'm going to tell you about it later. Let me finish this. Normally this CO2 will equip, okay, so we got, let's see, I'm getting a little off. The end products are humus and CO2, so we know that. So we got all that CO2 in the air, and we got these wonderful particles that I'm going to talk to you about in a minute. Normally, this CO2 will equilibrate with the air. But when the soil is tilled, CO2 is released to the air and adds to the problem of global warming. Okay. Okay. So I think I basically said this. This is just a little goodie. Photosynthesis occurs in the plant. Also, a little bit of photosynthesis can occur with the microherd, like with the algae and things like that. Okay, but anyway, you get CO2 from the air. You get dead plant material and dead animal material on the soil. Those go into the soil, and the microherd uses them for its own work, its own building. And then what's left can go off as nutrients, go up into the plant roots. But then, and here's this carbon humus that's very stable, and it's kind of an idea of like little particles. What they do that's so wonderful is they attach positively charged cations, which are nutrients, like calcium, like potassium, even NH4, ammonia. And they attach large amounts of them. And they hold them there until there's a need, a call for that. Okay. So the way they're displaced off of there is by hydrogen ions, which are also positively charged. And the thing is, if your pH is above 7, there's probably no hydrogen ions running around. pH below 7 means having hydrogen ions free. Okay? So if you're below 7, then the hydrogen ions, as there seems to be a need in here, this is all equilibrium, doing its thing. For a calcium ion, a hydrogen will go in there, and the calcium ion comes off and goes into the plant and does its thing. Gets used. It's a beautiful, beautiful system. Okay, so photosynthetic organisms, for instance plants, convert CO2 to carbon chains that make the biological molecules, DNA, protein, fats, etc., that are the building blocks for the cell. Animals get these molecules by ingesting plants, and CO2 is the end product of this digestion, or what I should have put in there, humus also. Yeah, any questions? You guys know this pretty much. Okay. So the microherd is the one that makes the humus. As the microherd metabolizes its own food, one important end product is humus, a particle of stable carbon plates that can bind to certain basic nutrients and thus act as a reservoir for a storage unit. These nutrients are needed for plant growth and are made available as needed by the mechanism I just talked to you about. Their release from the particle requires a pH below 7, and the process is known as cation exchange. Humus makes soil or compost very dark brown. So adding dark, what do I want to say? Decomposed, thank you. Well decomposed compost is really good for the soil. And here's one of the things I found out when I was reading about this. If you do this, you get rid of all the rest of the press. Okay, you do all this composting and you put it in your soil, and I don't know how long you have to do this. Depends on your soil, really, how good it is. But you do this for a while, and the pH of the soil will come down to 6.4. Now that's out of an agricultural journal where they did these studies. I don't know that it works perfectly. I'm going to try it, because I'm going to keep track anyway at home. But the idea is that that's part of the equilibrium where the nutrients are best available for the plants. Da-da, da-da, da-da. And you don't have to amend it to bring it down. You have to wait. You have to put lots of good, rich stuff in there. Okay, nitrogen, again, only the microherd, creatures like that, can fix nitrogen. We call it nitrogen fixation. It's absolutely critical because nitrogen is just as critical as carbon for life. It's required for macromolecules synthesized in its various nutrient forms by the microherd. And basically the end products are of nitrogen fixation, NH3, NO3, N2, which goes back up into the air someplace. It is not sequestered in the soil. It doesn't have any humic particles, humic acid particles. It doesn't have any that it can attach to. This is a negatively charged. Now, NH3 can become NH4, and it's positively charged, so it can be on a humic acid particle, but NO3 is negatively charged, and it has no place, not allowed. Which is one of the reasons why it can be leached so easily. So, it says, unlike CO2, nitrogen is not sequestered in the soil, and so is a limiting nutrient. It is not easily stored on humus, for instance, and so can be leached from the soil by excess water. The other thing is, this is a slow, I don't understand why, but this is a fairly slow process of going from N2 in the air to NH3 to NO3, which is really the form that is most useful to take up. It's a very limiting factor. That's why they add nitrogen and see the plants grow faster and greener, but not realizing that this equilibrium is what lasts, keeps soil fertile. So if you get greedy, you pay for it. Okay, effects of size, that's pesty and herbicides. They kill the microorganisms and decrease the microherd's ability to metabolize nutrients. There are a lot more nutrients than carbon and nitrogen, a lot of things. I think there's 30 critical, basic, absolutely have to have. And they are recycled, recycled, recycled. They're all made some way or another by this microherd. So the microherd, so these sides will kill organisms in the microherd, and then that cycle gets broken down. The sides kill the beneficial insects above ground and destroy the ability of the microherd to adapt. By adapt, I mean really genetic adaptation, either genetic or population. Adapting means we've got a stressor here. We either need more of this guy that does this, or we need something that does something a little different, recognizes something different. So this is the other thing about diversity. This huge diversity of stuff up here, within that is a great deal of genetic diversity. Those guys are not all identical. So you get a stress, and this guy can handle it better than that guy, so this guy's going to make more babies. Okay, so you're going to have more of them. That's adaptability, of the genetic adaptability. If you don't have a huge number of things, you're not going to have much. You have small populations, like what are those wonderful critters? Can't think of them at the zoo, where their populations are now so low in the wild that they have no genetic diversity left and they have no way to adapt.
Oh, the rhinoceros.
Thank you.
Yeah.
That's exactly right. That was years ago too,
Yeah.
and it's worse now. Yeah. So genetic adaptability requires having a fairly diverse and large number of things. Okay? All right. Kill beneficial insects above ground, destroy the ability to adapt to soil conditions, to protect against pests or climate conditions, and to maintain equilibrium. The cost to counteract all of these needs is very high, ecologically and economically. Try to do it with chemicals, try to do it with fertilizers, da-da-da-da-da. And ultimately we can see absolutely now, that's going downhill. A really possible thing to do if it's done well. Organic farming depends upon a healthy and genetically adaptable, and that's why I emphasize that genetic part, because that's absolutely crucial. Micro-herd that can efficiently cycle nutrients from organic material in the soil, but that can also resist pests and other challenges. It is this potential that is the most powerful for sustainable agriculture. Composting is the way to build the micro-herd. Compost very often doesn't have dissolved nutrients, at least, so much of the nutrients that the plants need. It has other more complex organic material, but it's composting is about building the micro-herd and giving it food. Okay. So here's a toolkit for organic farming. There's a whole lot of stuff, and you can all think about this, I'm sure, pretty much. Intercropping. What's the problem with monocropping? Vulnerable to what?
Yes.
Pests?
Depletes nutrients
Depletion of what?
of certain things in the soil.
Depletion of nutrients in the soil. Depletion of the micro-herd. Boring, yes. Ugly. Mainly, the major thing is you lose the diversity of the micro-herd. Okay? So if you instead of do that, you do intercropping, you've got a whole lot of resources. They may be over with that group of plants right now, but if something goes wrong, they can move. They got all those little tunnels in there and all that stuff, right? And then they reproduce and they respond. Yeah. So it's like, I can't think of the right one. Anyway. Okay, crop companion planting, same kind of thing. Intercropping. I never plant in my beds, my vegetable beds that are about like 4 by 8 mostly. I never plant anything without somebody else with it. All throughout, they're all different kinds of things. And they're happy. They grow that way. Okay, cover crops, absolutely. And there's a lot about this that you can read. Legumes and things like that. Anything that's going to build the nitrogen in the soil is very, very useful to use as a cover crop. And I use them as part of the intercropping, even like in the winter.
Can you give some examples?
I'm sorry?
Can you give some examples of cover crops?
Yes. Alfalfa is one. Now, I don't know, other than drinking tea, I'm not sure what else you can do with that, but you can compost it. Basically, when you're ready to get rid of it, you compost, you dig it right back into the soil, you put it on the soil. When mustard all over the place this year, and 2 acres of mustard, right? Every one of those got pulled out and laid down. Seeds and all. Because they are full, mustard is full of nitrogen. Yeah, so, full of what? Say that again. Oh, that one. Okay, well, too bad. Is it a good or a bad bug? Bad bug. I'll go look it up. Well, not to worry, because it's going to move, right? It's going to go somewhere else. Yeah, get composted, whatever. Yes, ma'am.
So you said you laid it down. Did you just pull it up and put it on top of the dirt? Did you dig it in at all?
Any place where it wasn't in the dirt. It's in the walkways, up on the hillside. Yeah, or in the crops, because I don't try to grow my crops over the summer. It's way too hot, too much water. But I cover them up. I grow a cover crop if I can, but even when it dies, I just leave that there and let it go into the soil. Yeah.
And you don't cut it up so it decomposes?
I would like to, but you know what, mustard is hard to cut.
Yeah, okay.
I have a little chipper and it won't touch it. It says, no way. So I got a lot to do, so. And take it the easy way. Okay, Appropriate crops, instead of growing something that should be grown in East San or in South San Diego or West San Diego. I live in East San Diego. I grow things that are appropriate for my hot weather. Quality seeds. Quality seeds. Okay. I use a lot of heirloom things, not completely, but I make sure I get organic seeds at least. Pay labor decently. I pay $15 an hour when I have a guy that I have to have help me, because it's worth it. If he works hard, and it is worth it. Okay. No till. I don't till. And I was just explaining to somebody what I do is with a pitchfork. Now, my garden's been going for about 4 years. My new ones. I had to start all over again because they had to replace the leach lines on the septic tank. It tore everything down, all the time. So now I had to go. So this time I did it in a different way. But so they brought up all of the decomposed granite, right? Anyway, so for that first year or two, I did have to really break it up. But what I use is a pitchfork, and I put it in there, and I just play a game with it. Hey, baby, let's go. Okay? That's that loosens it, but it doesn't destroy all of the structure. And then you start pouring your compost into that, and it gets down in there better, and then you water it, and so on and so forth. So, and I don't ever walk on it. I do. Sometimes I put walking bricks if it's big enough that I need to walk. I don't ever walk on the soil. Drill seeding, I've never tried that, but I understand that a lot of that is done in agriculture these days. So that you don't have to do any digging, you just drill down and leave the seed there, and that sounds perfect to me. Composting, big deal. Yeah, absolutely. Drip irrigation, yes, although I spend a lot of time working on it, trying to make it right and get the right hoses and da-da-da-da-da-da-da. Rainwater collection, just this year I moved up to 4,500 gallons of rainwater collected. And fortunately I have a husband that builds things. Well, I helped. I had to make sure everything was level, so I had a lot to do. Whatever you can do, that's most of it. That was wrong. That's off of the roof of our house. And they're not that bad looking either. So all this stuff, it just takes time to start thinking it through, trying it out. But ultimately, it makes a big difference. It makes you much more independent, like the water bills. Okay? Just like that. It's really worth it. Okay. Traditional guidelines. This is basically out of the non-industrialized world. Live on or close to the land. Follow its seasons. Return everything that is not edible or usable back into the soil. Allow the animals to fertilize the land. There are people that have set up pastures, and so they'll pasture animals in one place for a while, and then pasture them somewhere else for a while, and so on, and things like that if you have that much land or that many animals. I have a lady who raises horses, so that's what I get. It's a community effort. It should be a family effort or a small neighborhood effort. We're all happier when we're working with people, when we're together and sharing. So to the extent that you can do that, it really helps. And other people have good ideas. I was always surprised. I thought I was so smart. And then somebody would say, and I, oh, I'm not that smart. Other people are smart. So, yeah. Okay, 5 best management practices for agriculture. All right, this is a handout that you have. This guy, Altieri, was at Berkeley from maybe the 70s, or at least the 80s in the Department of Entomology. I just ran into an article by him the other day online that was absolutely wonderful. He's from South America, and he writes beautifully. You can Google him and find something to read if you want to do that. But just the way he put things made me feel good, because it's not saying, okay, I'm a Westerner and I'm going to try to da 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 da. No, here's how it's been done for for a long time. And it worked. And it's not fancy. It was the involvement of people with their land. Okay, so that sounds like a good thing to me. And this particular list of the 5 BMPs comes out of the article that I have up there, Archaeological Principles for Sustainable Agriculture. So, number 1, recycle and reuse all available biomass, crop residues, cuttings from surrounding trees, shrubs, manures in order to replenish and constantly restore soil nutrients. We talked about that. Grow plants by building soils, focusing in particular on soil organic matter and soil biotic activity by, for example, adding manures and promoting the growth of the earthworm population. Earthworms are wonderful. You can, grow red wigglers by themselves and put them back in your soil. It's wonderful. Minimize losses of growth factors above and below ground by protecting the soil from direct solar radiation, strong winds, and erosive water flows. Now, one of the things we hear people talk about, they've had pests and they want to solarize the soil. Evidently, that's one of the worst things you can do. Okay, because that's going to dry it out and that's going to kill so many things. Every time you turn it over and expose it to a hot sun, it's going to do so much damage. Better, and what you really want to do is keep the soil shaded, manured, not manured, mulch. Thank you. Okay, I'm so glad you guys are. You think this is happening to me just now, but I used to teach. I taught almost every grade level up to graduate school, and never have I been able to remember all the words I needed. And somebody would, and I would always give them an A. Okay, so maximize diversity in order to increase resilience, and that's the intercropping and all of that. Enhance beneficial biological interactions and synergies so that natural ecological processes can work to enhance rather than undermine agricultural production. And I'm not sure exactly what he has in mind to do with that, but I love the idea. I mean, entomology is wonderful, and all of those organisms are wonderful, so I think it's worth some serious study to figure out, okay, what can I do to attract those things? Okay, and there, in North Vietnam, the rice paddy, with the people working in it. And you see, I know they are because I walked out there to look at them. These are other little plants. Every one of these divisions here has a boundary by other kinds of plants. I don't know what they are or anything. I really loved North Vietnam because it was, North Vietnam in general is still an agricultural nation, an agricultural place. And this is way up north, very close to China. And you can't get there except by, I guess you can drive there maybe, but basically the way people get there is on the overnight train. That narrow, there's about there, and it was pretty exciting, but I made it. But people don't go there. It's not overloaded with tourists. It's wonderful. And the last thing I want to say is just about where this has to be, where this has to happen, is here us at the urban level. Wherever we live, wherever you as master gardeners obviously are pulling that together in a really, really big way. School gardens, we've got that project here. Community gardens, we've got that project here. Backyard and front yard gardens. You'll have, there are all kinds of ways you can influence people to do a better job of whatever it is that they are trying to grow. Okay? Climate appropriate plantings, composting, water saving, and on and on and on and on and on. I mean, it's wide open. The need is really there. The interest is there. People would love to know more about how to do stuff like that. And the last thing I'm going to do is tell you about my project, and I'll just take 2 minutes. I hooked up with a woman who's very involved, Nancy Helt is her name, she'll be here to talk to you, I understand, down the road, involved in community gardens, among other things. There were 40, and there are more than that now, in the county, and land is donated by somebody, and then for a very minimal charge, individuals can go in and farm a fairly small plot. And how they're set up is very individual. It's not programmed. Some of them are just 20 by 30 piece of land, period. You get in there and you put your own fence and you put your own bed. Others have nicely built beds and nice water supply. Just all kinds of different things. And what I felt in talking to people was one of the things people would like is to have somebody come test their soil. So I thought, okay, sure, I can do that. And I bought this great big testing kit and so on. And started going, you know, test it for nitrogen and phosphorus. So what? What does that tell me? Just, oh, you need to add nitrogen fertilizer? No, that's not going to happen from my mouth at least. So I did some studying and I came across this very old process, thing of cation exchange capacity. It was the first article I read, the earliest article I read was from the 40s, I think. And it's used a lot in agriculture, I guess. And what it is a measure of the ability of the soil to hold these positively charged cations, which indirectly means the amount of humus in that soil. Indirectly. And humus in soil is a wonderful indicator for the wealth and the health of that soil. Okay, so what did I need? How was I going to do that? Because I have a lab in my house, a big lab at my house. I used to do water quality measuring throughout the county, and I still have that lab there, okay? Because I love science. So I realized I had 2 meters that I needed from those days that I could use. One is a pH meter, and one is a TDS meter, total dissolved solids meter. Okay. And I still have them, and I put new batteries in them, and so on. Turns out you can convert total dissolved solids, which they also call it for salinity, but really it's just total dissolved solids in the water that have some kind of a charge. Okay. You can convert that to cation exchange capacity, just a numeric change. And you can determine that you have good soil that's going to work with this if you have a good pH. Okay, I got you. Right there. I got 2 minutes, 1 minute. Just what? Okay. So, with those 2 meters, I can go out, and the other thing is I bought a little centrifuge because humus is very, very light. You can't pull it down at 4,000 RPM. You can't pull it down. Everything else comes down, but not that. So I can put that in and centrifuge it for 20 minutes, and what's left is humus. So with those things, I can go out and talk to people, but also do this testing on site relatively easily and offer them something. And that's what I am trying to build. And I've got my first ones coming right up this month, actually. I thank you very much. You've been a lovely, lovely audience.
Thank you for our walk around the